Okay, number 3, we had just finished solving this equation, or this inequality, and we have x is greater than or equal to -5. And then we graph the solution set, everything to the right, and used a bracket. Okay, there are 2 ways we can write the solution. One is in what we call set notation. This is where you take the solution you get and write it inside braces, and the braces indicate that this is a set, okay, in mathematics. The set of all x such that x is greater than or equal to -5. And then that's it. That's the end of it. That's the set notation, which is probably the simpler one. But the one you're going to use the most is going to be what's called interval notation. And to me, it's easy to write the interval notation if I can see my number line over here. Okay? An interval means what? If I say an interval of time, then you think about, well, a starting point and a stopping point. Like if your class begins at 8 and ends at 9, that's an interval of time. So for interval notation, I want to know, where does this solution set start and where does it stop? Okay, well, x is greater than or equal to -5 begins at -5 and goes where? Forever to positive infinity. If it's going to the right, these numbers are getting larger and it's approaching positive infinity. This is a symbol for infinity that we use, and there's a symbol on your keypad in My Math Lab where you can type this in. Whatever notation is on your graph is what's going to be on your interval. So if I have a bracket on the -5 on the graph, it's going to have a bracket on it here. And then we always put a parenthesis around infinity. So this means that my solution set includes -5 and then everything above -5. So here's a way that I just use to remember this, okay? And this only works if your x is on the left side. But if x is on the left side, you can look at your inequality as being an arrow. If it's pointing to the right, you're going to shade to the right. And in your interval notation, positive infinity is going to be on the right. You'll have the number first and then positive infinity. Okay, if it's the opposite, let's say if we go back up here where I had number 2 was x is, no, not number 2, number 1, x is less than 5. If we look at that number line again, here is 5. I would shade which direction? Okay, this is separated, a separate problem. X is less than 5. We'd go to the left, and because it's just less than, I would put the parenthesis. So what would my interval notation be? Well, where does this start? You know, read it from left to right. This is going toward my negative numbers, which is what we would call negative infinity. So my interval would be from negative infinity up to 5, and that's where it stops, and it doesn't include the 5. So parentheses around both. Okay, parenthesis here because it does not equal 5, it's just less than 5. Okay, so you need to look at the directions on the homework. They will tell you which way they want you to write the solution, and so that's how you should, you know, have it typed in. Alright, let's look at a few more examples. If we look at 3x is greater than 9, it says graph the solution set and write the solution in interval notation. Okay, I would solve this the same way as if it were 3x is equal to 9, which means I would divide by 3, so x is greater than 3. Then we want to graph it, and I only want to see, you know, a number to the left, a number to the right of what's on your solution. And on the homework on My Math Lab, they'll already have the numbers written out there for you. So greater than 3, Again, since x is on the left, it's pointing to the right, I'm going to shade to the right. And then what symbol am I going to put it through? If it's only greater than, we use the parenthesis. And then I want to use my interval notation. So it's going to look just like what I have on the graph. So it's going to be from 3 with a parenthesis. If it's going to the right, it's going to go to positive infinity. So this would be my interval notation here. Okay, number 5 says negative 2x is less than or equal to 10. Same directions. Okay, watch this one for a minute. If I divide by negative 2, I would get x is less than or equal to negative 5. Okay, let's check that. If I'm going to check, I go back to my original problem. Less than or equal to negative 5 will give me something less than negative 5. Less than negative 5, we could put in negative 6. And if this is correct, it should give me a true statement. Well, positive 12 less than or equal to 10. Positive 12 is less than or equal to 10. That's not true. Okay? And the reason is because of a very special rule that we have to work with inequalities, and that is right here. If you divide by a negative number, then you must flip or reverse the inequality sign. So what I did is not actually correct. Okay, this would be the correct way to work it out. Negative 2x less than or equal to 10. I'm going to divide by negative 2. And any time that you divide by a negative, you've got to reverse or flip this inequality sign. Now it keeps the or equal to, if it's in the problem, it's going to keep that. But I just flip the direction that this is pointing in. And so I get x is greater than or equal to negative 5. Okay, so now if I wanted to check that, I go back to the original, give me a number greater than negative 5, which would be negative 4, and I get 8 is less than or equal to 10, which is true. Okay, so that tells me that this is the correct solution. Okay, so if I want to graph this on the number line, negative 5 greater than, it's going to go to the right, equal to means I'm going to have a bracket. So that's my graph, and then my interval will look just like this. Bracket, negative 5, going to the right means it's going to positive infinity. Okay, so I want you to make yourself a note. This would be my solution, but make yourself a note that when dividing by a negative, you're going to need to reverse the inequality sign. Okay, when dividing, and we could put in here or multiplying, because sometimes if you multiply by a negative, but that doesn't come up nearly as much as the division. Okay, when you divide by a negative, always reverse the inequality sign.